The next 5 questions all refer to this graph at the right. The first one asks the limit as x approaches 2 of f of x. Well, as x is approaching 2 from the left and the right, the y values of the graph are heading for 0 from both sides. It doesn't matter that the value of the function is 1 up there. It's where the graph appears to be heading, or what the behavior of the function is in the neighborhood of x equals 2. The value appears to be heading for 0 from the left and from the right. And so the answer to number 2 is A equals 0. Second, the function is defined on the closed interval from -1 to 3. For what values? The function being defined and being continuous are two different things. Defined just means that there is a value, a y value for all x values, or that all x values are in the domain of that function. So it's saying the function is defined on the closed interval from -1 to 3 if x is not equal to 0. But the function is defined at x equals 0. If x is not equal to 1, but the function is defined at x equals 1. X equals 2, the function is defined at x equals 2 and at x equals 3. So the function is defined everywhere in the closed interval from -1 to 3. There is a y value for every x value from -1 to 3 inclusive. So the proper answer to 3 is E. And I'll scroll up a bit. In question 4 it says, on which of the following intervals is f continuous? Well, continuity and the function being defined are two different things. To be continuous, we must be able to draw the whole segment of the curve without picking up our pencil. And so the options are -1 to 0 inclusive. Well, -1 starts out okay. The function is continuous at -1. However, it doesn't include the point at x equals 0. So the function is not continuous on that entire interval from -1 to 0, because at 0 the value, we would have to pick up our pencil to draw in the value of the function when x is equal to 0. Second, x is 0 to 1 on the open interval. Well, from 0 to 1, but not including 0 and 1, then we would have all the points to the right of 0, but to the left of 1. And we can see that we could draw that whole section without picking up our pencil. So that one appears to be the answer. We go on from 1 to 2, we have the same problem in 1 to 2 on the closed interval, but we don't have a closed interval there because both endpoints are not included. I cannot draw the value of the function at x equals 1 and continue drawing the rest of the curve without picking up my pencil, or drawing the value of the function at x equals 2 without picking up my pencil again. And we have a similar situation from 2 to 3. We have an open circle at x equals 2, so I can't draw the value of the function at x equals 2 and continue the rest of the curve all the way to 3. So the proper answer there is B. And I'll scroll down. In question 5 it asks the function f has a jump discontinuity at which of these? At -1? Well, -1, that's the end of an interval. We wouldn't consider that a jump discontinuity. At x equals, next, at x equals +1, there is a jump discontinuity. At x equals 2, since the behavior from the left and the right is the same, we consider that a removable discontinuity, but not a jump discontinuity. At x equals 3, that's the end of the interval. So the proper answer there is x equals 1. And 6, the removable discontinuity would be at x equals 2. We could remove the discontinuity simply by changing 2, 1 to 2, 0.